Hello and welcome. I thought I would spend a little bit of time talking about Deliverable 7 today, given that it's the last one that you've got to do. Hopefully I can add some insight. One of the things that struck me as I took a look at what the instructions are, you're going to, I would expect, be able to reuse a lot of what you did on the previous deliverable. In fact, I would expect you to, including this the CN2, the rule inference, the bagging, boosting, nearest neighbor, all that stuff seems kind of familiar, right? So the basic idea here is to I would recommend strongly reusing most of the code that you've previously written. Perfectly fine to do so. And in fact, I started just for fun, taking a look at your code and then seeing what it would take to turn that into, I lost a window, into my code, so to speak. So I took a look at stepping through it and turning it into a Jupyter notebook. So all I'm basically doing is combining it into different cells so that you can step through them one at a time. Took your code for doing your evaluation of the classifiers, and also modified slightly the data loading to handle both, so I can give it a full path, because I do some interesting stuff with Anaconda and notebooks, so I need to give it a absolute path, and then also modifying it so that it talks about test, train, and orange. And then basically leaving most of the rest of it along so that it hopefully will require minimal rework. And so thus far, I'm pretty much to the point here of having kind of done what, moving it over. Then the next step is to go through and take a look and see how many nulls you've got. And you're probably going to have to spend some time figuring that out, because there's quite a few nulls. And that's a nice set of code you've got there to basically count the number of nulls in each column. Quite handy. Also, a little bit more things. One of the things you want to do is take a look at the columns of any data set whenever you're doing this sort of processing, and see what's there. In this case, your target is going to be this survived column, right? So I modified it from your label to basically to say survived instead, so you can take a look at what that distribution looks like, and how many of them are unique, and what's the value counts. And so you can see everything has a valid value. And so here, all I did, just so that it lined up with your code, was basically a cleaner way to do this, but I just, with minimal changes, changed your column from survived. I'm basically renaming it target, and probably should have done that instead, or I should have done that instead. So rather, I just made a copy of it and then deleted the original. But one of the other things that there's a few things else you're going to want to get rid of here. Just kind of glancing through it, you don't care about their name, so you're going to do, borrow as much of this as I can. You don't care about name, and there's probably some other ones, right? So that'll be part of what you have to do, and part of how I know you're going to want to get rid of name is because down here it was complaining about somebody's name, right? It's not a float. So that's actually probably a good way to see what ones you need to get rid of. Probably should do them in mass, but this is kind of one of the things with notebook development. You may need to go and revisit things. So I've already got rid of the string, so that might actually be what is cabin? All right. So again, this part of what I'm doing here is hopefully showing you kind of how I approach these things. So cabin.unique. What is that? Yeah, you don't care about that either. So you're going to want to, and this is one thing that you can kind of do with notebooks. I don't know if it's necessarily a best practice, but you could go through and say, okay, well, and you can do these cleaner and consolidate it later, but maybe it's exploration that you're doing, so you can say, well, I don't want cabin either. And let's be a little smarter here. So we got cabin. What about, what's the other object? Embarked. Probably don't care about it either. Yeah, you don't care about that either, so you want to get rid of embarked. sex is probably going to need to be mapped as to something else. So anyway, I'm not gonna obviously do this all, but kind of showing you a bit of what I typically do, and then you may want to then do. See if this works. So display, kind of a little prettier way of looking at it, right? Than some. So doesn't look too bad. Ticket, that probably needs to go too. So the challenge you have is if you do this, and better yet, you probably want to actually clean it up and put it up here, and then move name down into this list, right? You can do all this, but you got to make sure you go back and recreate this data frame, right? Because where do we load it in? Here? Oh, we'll just start here and go through. Otherwise, you'll get some errors, right? And this doesn't work anymore because embarked is gone. And probably that's gone too, or not. Okay, that's the data frame. So now we're getting down close to what it is, and you're going to do a map here from, and you had that code, nice handy little, where was it? Here we are. So you can do this. There's a way to do it with with rename and whatnot, but sometimes you just focus on getting things done, right? And you are less concerned with the elegance than you are just getting it finished. Sex dot unique. So what are those values that we have to deal with? And it is males, so we're going to want to map male and female. Doesn't really matter as long as you know which one is which. And we're doing sex, and we're going to say that is gender. And then drop sex. And with any luck, we now have gender, and you've got target, and all of that will probably work. So then going ahead and creating the classifier, and then let's see what happens when we call it. So it's still not locking something, so there's some not numbers that need to be dealt with. So that's back here with the nulls, so you're going to have to do a fair amount of cleansing of the nulls, of setting them with either appropriate values or removing them. So that's up to you. However you want to do that, just make sure you document which one it is. So hopefully this gives you a little bit of insight into how to address these sort of problems. And we can go ahead and walk through next the assignment itself, right? Because I've talked about it, but sometimes a little more talking will go ahead and help. So basically, like you're supposed to write a Python program. This is a departure. Well, no, it's not. Too many classes. So you're to write a program in Python that basically uses those four sklearn classifiers, and then also utilizes orange as well, and the rule inference. And that's one of the other things I was going to show is, where's orange? I thought I launched it already. Because one of the things that I've done, and hopefully this will work out on a different window, so let's switch. Well, I'll drag it over. That's better. Bear with me one moment while I'm navigating. So I did this early on for fun to see what one can do with orange. So this is kind of some cool stuff. Some additional things probably need done with it. So Orange has the ability to basically know things like the files, and that's part of the nice thing with the course project data. There we go. So this is the file that's given to you. It's already got the target set up, right, so that you know that this is what you're trying to target. And this one's the table that you've got there is relatively limited number of categories. In fact, I think we still had a few more than those, right? Although you're probably going to want to get rid of ticket. What do I do? Restart the kernel. So we still have some other ones here that may or may not want to be kept in, right? So this, and if you look at what's Orange is using for the classification, it's basically saying status, age, or gender. So gender, P class would be status, and so on. But the nice thing is it kind of tell it what the target is. Kind of died there for a minute, so probably write the code. But what Orange will do for you is graphically you can do a lot of the same stuff, not everything, but I actually did it plus a few more other things here. So I've got, I don't know that there was a boost. I'm not too sure there's a boost. But what I did was you load the file in, and you can take a look at the file with this data table control, right, that shows you the contents of the data. I can't really zoom to make it bigger. I can zoom to make this bigger, but not the individual controls. So I can get rid of help, and I can make it even bigger yet, right? So you can use this test and score control or widget or whatever you want to call them to basically chain together a series of classifiers and a data file. And what it does is run the metrics that you care about on all of those different classifiers. So in this case, you're asked, I believe, AUC was one of the things you're told to talk about here as far as performance, right? Compare the performance metrics. I guess it doesn't spell it out with those in 5B. I think that meant probably 6B. But you basically got the various metrics that you're used to seeing, F1, area under the curve, CA precision and recall. And so you can actually organize them based upon whatever it is that you care the most about. If you care about precision or recall and so on. Then you've also got the ability, I didn't actually put it on the screen here yet, but you can do a confusion matrix. And it'll show you per classifier what the confusion matrix looks like, right? So I was hoping that would get bigger, but no. You can see, well, the CN2 rule inducer, how did that do? And decent, but not great. I mean, 68%, it's not too bad. You can take a look at K nearest neighbors with probably 9 neighbors. I assume that's what the 9 means. Yes, 9 neighbors. And that's one of the nice things too, is that you can actually name these things so that you can then, whenever you assign them a name inside of the control itself, it shows up both inside of here, right? So you know which one of those were, and you could actually have multiple K nearest neighbors with different values for n if you were so inclined. But also you can see them in the confusion matrix that's produced. So we can see here 68 not and 65 not so great, and 30s on the misses, 27, 22 on the K nearest neighbors with 9, 8 a boost, 77. Using a neural network, 77. Naive Bayes, 79. Stochastic gradient descent did reasonably well at 79 and 72. So in each one of those, not too bad. You can also, it's kind of hid down here, but at the bottom there's like a report you can produce. And you can actually save, I guess it's only doing if I do it on this one it's better. You can actually produce a report and it basically can save it off to some format. In HTML, or I believe there was another choice to a PDF if you're so inclined. So that you could actually save it off and use it as a work product of some sort if you need it to be. And the report is not the most riveting thing you'll ever see, but it isn't bad, right? It's showing the confusion matrix of one of them. I guess it's K9 because it's selected, and also more importantly, you can kind of see them all in a nice single view. And which one of those you would pick kind of really depends upon the situation. Sometimes you want to consider the misses and which way you're missing, right? So say you were writing a tool that examined textual documents for signs of authors not being the person who says they are. So basically a form of plagiarism where maybe you outsource the writing of your papers to someone else, or maybe you just take someone else's paper. One way that you can detect plagiarism, aside from the approaches that most of the tools that the universities use, which is they just simply look for similar fragments, and it's essentially a pattern matching sort of approach. Another approach is to calculate metrics based upon various segments of the paper, either using overlapping windows or whatever else it might be, so that maybe you calculate things like the readability level of a given paper, the types of mistakes they may make. So if they're writing an APA and they're putting a citation on the last sentence of their paragraph, probably is a mistake. There may be exceptions to that, but as a well-written paper with the last sentence of your paragraph should be a summation of the point of the paragraph and not introducing any additional evidence. Evidence should be introduced in the middle of the paragraph. Also, you could even have it to where overcitation is detected. So if you have multiple sentences together and each one of them has the same source cited at the end of the sentence, it's overcitation. It's a form of a mistake. You shouldn't cite that way. The point of all that is that you might use these various approaches to calculate what's essentially a thumbprint or an author identity metric, so to speak. And so you could take that and compare it against a given paper to determine what are the odds that these 5 papers were written by the same person, and come up with a prediction based upon that. And it's essentially a classification problem then at that point of clustering around authors. And so given all that, you wouldn't want to err on the side of making a mistake, right, of saying that it's a false positive. So you say that it's plagiarism and it's not. That would be pretty bad, right? So in that situation, you would pick a classifier or a clustering approach that minimized, actually it'd be classifier because you actually have outcomes, right? So you'd minimize the false positives, even over potentially a false negative getting through. So you say that it isn't plagiarism, but it really is, but it's worth letting more of those through than tagging somebody with potential plagiarism that isn't, right? Just as an example. So that's part of the process you go through whenever you're doing this sort of thing. And this basically kind of shows the silhouette score of k-means. And basically what it's saying is that looking at from 3 to 30 clusters, the magic number based upon a silhouette score is probably somewhere in through here, right? But it's basically similar kind of to an elbow sort of approach where you'd pick somewhere in through between 10 and 6 clusters. So that's where 9 probably isn't a bad choice, and that's where part of why I'm using K9 in this case. Think I can get a scatter plot out of that. Maybe not. Yeah, it's only giving me the silhouette, so that's not going to work. That's a scatter plot of the distribution. So here, it's that. What about that? It's a little better, but oh, here we are. So female and male, and anyway, I'm getting off script. So with that, I'll go ahead and delete that and move back. So this just basically gives you an idea that maybe not everything inside of a given assignment could be done with this sort of tool, but probably a lot of it can. So something to think about. Let's try it this way. Oh, that's nice. Yeah, it's not like that. But again, it's a trade-off, and when you're doing data science, you may use these sort of tools for a quick sort of experimentation, but when it comes time to do it for real, you're going to write some code. That's just the nature of this business. So with that, I'm going to go ahead and wrap this up. I've rambled for probably too long. If you have any questions about your assignment, let me know. That's what I'm here for. Stay safe, and we'll talk again next week. Keep in mind, as a brief reminder, 9 days, 7 hours. You're doing great. One more to go. Nearly there. You're in a whole lot better shape than some of my other students, but finish strong. And I look forward to seeing your assignment. So stay safe. I'll talk to you again soon.